You're making coffee when something feels off. Sunrise comes a little earlier, shadows look a little longer, and the weather forecast starts missing by a mile. Astronomers crunch the numbers and confirm the unthinkable. Earth has slipped into a slightly different path around the sun. Not science fiction, just celestial mechanics with a new setting. What changes first, and how far could it go? Before we begin, I would appreciate it if you could give us a like and subscribe. Earth's path is already a gentle oval, not a perfect circle. That oval is our grand metronome. It sets the rhythm of seasons, ocean currents, monsoons, migrations, crop calendars, our entire civilizational clock. Nudge the metronome and every instrument in the orchestra adjusts. How could a nudge happen? 3 broad ways: a close gravitational encounter with a large object, a velocity change after a giant impact, or slow accumulated tugs over long times. Any of these doesn't send Earth flying in a straight line. It settles us into a new oval, maybe tighter, maybe wider, maybe more stretched. Each option writes a different future. Move a bit closer to the sun and we receive more energy. Heat waves lengthen, nights cool less, and the global water cycle spins faster. More evaporation fuels stronger storms where air rises, while subtropical belts can dry out harder. Ocean conveyor belts, those heat-moving highways, rebalance, making patterns like El Niño more erratic. Crop zones march poleward. Forests face longer fire seasons. Insects and plant pests expand their range into places that once kept them out with cold. In everyday life, this feels like the toughest summer ever, repeated, then baked into the new normal. Shift a little farther out and the mirror image unfolds. Less solar energy means longer, tougher winters and shorter growing seasons. Colder air holds less moisture, so some regions become cold and dry at once. Persistent snow increases Earth's reflectivity, bouncing more sunlight back to space and amplifying the chill. Rivers freeze longer, energy demand flips from cooling to heating, and food security becomes the headline challenge. Make the orbit much more stretched, high eccentricity, and the seasons stop being ruled only by Earth's tilt. Distance to the sun starts calling the shots. Near the close pass, the whole planet gets a seasonal energy surge. Near the far pass, a global energy dip. Result: sharper swings, shorter planning windows for farmers, and infrastructure designed for yesterday's patterns struggling with tomorrow's spikes. Daily life keeps one anchor. A day stays roughly a day, because orbital tweaks don't necessarily change rotation. But the year changes. Closer means a shorter year, farther means a longer one. That sounds trivial until you realize how much of society syncs to that beat. School calendars, harvest schedules, fiscal years, cultural festivals. Rewriting the calendar isn't just a page flip, it's a systems update. Tides. The moon still leads, but the sun adds a noticeable supporting role. Closer to the sun bumps solar tides slightly up, farther calms them slightly down. In certain bays and deltas tuned to resonate, that small shift can mean new records for spring tides or unusually quiet neaps. Week 1. After the shift is mostly quiet drama. Satellites and observatories notice precise timing offsets. Navigation models get patched. Weather models begin to drift. Energy grids feel surprise peaks. Airlines rerun wind maps. Insurers stare at spreadsheets. Markets twitch before the public fully notices. Year 1 replaces surprise with pattern. Closer orbit worlds pour investment into shade, cool roofs, heat-resilient crops, early warning systems, and water efficiency. Farther orbit worlds go all in on insulation, district heating, winter-hardy crops, and grid hardening against ice and snow. Health systems adapt to new temperature extremes. Cities add trees, reflective surfaces, and redesigned work hours. Decade 1 decides winners and stragglers. The leaders deploy climate-proof agriculture, greenhouses, vertical farms, drought-tolerant perennials, scale energy storage to ride peaks and lulls, and interconnect grids across regions, so one area's surplus covers another's deficit. Coastal planning updates tide maps. Mountain towns rethink avalanche and snowfall risk. Ports adjust to changed wind and wave statistics. Is there a point where a new orbit pushes Earth outside comfortable bounds? Yes, A very tight inward move could overload the atmosphere with water vapor and trap heat. A large outward move could lock in extensive ice and high reflectivity. Between those extremes, there's room to adapt, but the cushion isn't infinite. Could we steer back? In principle, yes, on civilization timescales. Concepts include controlled flybys of asteroids acting as gravitational tugs, a thin solar shade at the Sun-Earth L1 point to trim incoming energy if we are too warm, or very gradual momentum tweaks using lunar industry. None of this is a quick fix. All of it is hard, but it shows agency isn't zero. For individuals and cities, adaptation is local and practical. Hotter world, shade canopies, cool materials, green corridors, thermal codes that keep interiors safe without huge energy bills, reliable water, and early alerts for heat waves. Colder world, deep retrofits for insulation, community warming centers, snow-ready infrastructure, and seed varieties bred for shorter seasons. In both cases, diversified food supply chains, smarter insurance, updated risk maps, and education that treats planetary systems as homework, not background noise. There's also a cultural shift. We're used to thinking of astronomy as fixed and climate as variable. Learning that Earth itself is on a subtly different track would be a humbling reminder. We live inside a moving system, not on a static stage. But it could also spark a new era of cooperation. Scientists, engineers, farmers, city planners, recalibrating our grand metronome together. So what if Earth slipped from its usual path? For small shifts, it is not the end of the world. It is the end of the world as we knew it. Sharper seasons, new maps for food and water, and a premium on flexibility. For large shifts, we approach physical limits that define oceans, ice, and forests. In every case, the playbook stays the same. Observe carefully, understand deeply, adapt wisely. The sky isn't falling, it's changing. And when it changes, so do we.